Hi guys. Today we're going to talk about social science methods in ESM 230. And this week we are discussing both social science methods and bias. So I hope you have watched the video on bias. So I just wanted to talk a little bit about what social science is. And I'm going to do it just by showing the subjects, at least at Humboldt State University. I think this is derived from our university. These are the departments that are considered social science here: anthropology, critical race, gender, and sexuality studies, economics and management, environmental studies, although not all the options in environmental studies are social sciencey. Um, History, human services, international studies, journalism and mass communication, Native American studies in part, political science, psychology, and sociology. So, what these have in common is that they are very much focused on humans, as opposed to, say, science, which, one branch of science is astronomy, not really focused much on humans. Although there's probably a social science component of even something like astronomy. But anyway, so social science is very much focused on humans and how we behave and how we organize ourselves and how we relate to each other. So there's a longer list. If you want to go to Wikipedia, you could go in there. And there's a lot of departments that Humboldt could have, but if you want them, you could go to UC Berkeley or some other university and find them. This is what we got. So, just a quick recap of what we've studied so far in this course. We started out just, basics, critical thinking, scientific method, quantitative problem solving, gave you a little domain knowledge, water chemistry, and mass balance, useful for doing some quantitative exercises, and then bias, and now social science methods. So, why do this? Well, we, meaning you and me and the rest of the students in this class and in the Department of Environmental Science and Management and Environmental Studies, we are here because of environmental problems. Now, I could stop and, excuse me, I could stop and have a philosophical conversation on what a problem is. I'm not going to, but I did go down that rabbit hole, but won't for you. Environmental problems have root causes that can be studied by natural science. That's my expertise. That's mostly what I do. And a lot of this class is focused on those kind of methods, the natural science methods in environmental science. And you could think of some examples. Okay, that's not too hard to do. You do it. Like climate change, species extinction, eutrophication, uh, erosion, mm, all kinds of things. Invasive species, okay, can be studied by natural science, but humans cause the environmental problems, at least the ones that we study. I mean, you might say that some natural variation in the environment is causing a problem. Yeah, it's true. But largely, humans nowadays, with 7 billion people on the planet, humans are the cause of most major environmental problems. And humans are a component of the solutions to environmental problems. So we not only start the problems, but who's going to fix the problems? Well, I suppose if we just let things go, nature will eventually fix everything. But if we want to accelerate that a little bit and not allow human harm to occur and harm to the environment to occur, then humans are going to be the solutions to the problem. Okay, so this is a little philosophical. I hope this is sort of intuitive, but I just wanted to throw it out there and put it down in black and white for you, black and green. Therefore, because we cause the problems and we're a component to the solutions, we need to understand the human dimensions of environmental problems and how to include that understanding in our effort for solutions. These problems are not going to go away by themselves. Neither are people. Like it or not, we're stuck with ourselves. We have to deal with that. Now, I put this phrase human dimensions in quotes because it's kind of jargon. It's just, the human components. It's the parts of the problem that involve humans is what I'm talking about there. Okay, and just let's take a look at these are the two main majors taking this class, ESM and environmental studies. There's a couple people in other departments also in this class. I don't know why. Maybe they're minoring in this class. I don't think they're taking it for their major. But anyway, These are the majors, and these are the options in them. And so I just want you to scan down there and say, wow, how would social science be integrated, or which of these would need to have social science integrated into them? I would say all of them. So for eco restoration, well, why do some places need to be restored? What is it about I mean, sure, restoration methods themselves might be very sciencey, but maybe prioritizing which places should be restored might have a big social component. Also, the laws and regulations regarding your restoration activities are also social components. Now, I'm not going to go down this list. It would take too much time. You can do it yourself. I'm not going to test you on it. I just throw these out there, and I want you to pause and think about how the human dimensions are going to be important components of all of these. And now I'm going to move on. So anyway, this is a methods class, and the social science research methods you will use this week in lab are surveying and interviewing and coding. And I'm actually not going to discuss these much in this lecture. I'll just let that be taken care of in lab, except to just say the Likert scale. Let's all memorize that term, Likert scale. Hey, if you memorize what Likert scale is and you use that word in public, your perceived IQ automatically goes up by 5 points. It will go up 15 points if you do it with a British accent. Oh dear, that's a joke, and that might be anti-Britishist. Sorry, British people, I didn't mean to insult you, but it's true. If you think about how Americans perceive the British accent, they automatically seem more authentic and more intelligent, don't you think? I should do all my videos in a British accent. All right, I could do a survey and see what you guys think about that, but I won't. Anyway, moving on. Oh, yes, here's some factoids for you. So, yeah, Likert scale, here's some more factoids. Social science research skills fall into two categories, just so you know. One is positivist. Positivist basically is objective, quantitative scientific studies. That's my bias. I'm after the truth here, guys, and I want my truth to be supported by facts and data, well-collected data. Personal bias, I'm telling you. So if I were a social scientist, I would tend towards positivist social science. Well, what else is there besides positivist? Anti-positivist or interpretivist. So those branches of social science do not have objective, quantitative, scientific thinking. What do they have? I don't know, because I don't read that stuff. Because I'm only after, I told you my bias. But anyway, I guess it's a thing where people just like talk about stuff and try to convince each other of stuff without a whole lot of data. Maybe Freud would be a good example of an anti-positivist. I don't believe that Freud's psychological hypotheses were really backed up by quantitative data. You should look into some of Freud's thought. He's very influential in his day. To me, nowadays, very weird. Okay, which might tell you one reason why I tend towards positivism. Okay, so breaking down an environmental problem with a hefty human dimension component is a process, and you'll probably go through these processes in other ESM classes, such as, I don't know, environmental impact statements, grant writing proposals, different policy classes you might take. And so I hope when you get there, you're sort of familiar with some of these approaches. So, and by the way, these approaches don't just apply to academic stuff. If you have any kind of complicated problem in your life, this might be a good approach to take. So the first step is just to define the problem and then to break it down into different parts. How do you do that? Well, you can just sit in your chair and brainstorm them and write them down, scrawl them out on a piece of paper. And some of the brainstorm ideas might involve a hefty human component and others may not. Don't care about them, just list them. Later on, you can address these humans using the social science methods we're talking about in this lecture. Now listen, it's an excellent assumption that you don't know everything. I hope you're not so biased that you can't realize that you don't know everything. So you're not done after you personally brainstorm things by sitting in an armchair and thinking about them. You probably miss some stuff because you're not perfect and we are all full of biases. So form a team, get a friend or colleagues or whatever, and then repeat the brainstorming process. And wow, Sally just said something that I didn't even think about. That's a new thing on the list. Man, this teamwork is great. Also, your team does not know everything. Why not? Because they're just your friends and you live in a bubble or you're in a tribe. And so there's a whole bunch of other viewpoints you don't have. So involve stakeholders. A stakeholder, what's a stakeholder? I'll look it up. I'm not going to give you a definition. It's anyone who has an interest in the problem being solved. So I'm going to give you a really quick example of something that happened to me. I'm an academic. I'm a soft-handed schoolboy, and I love biodiversity, and I hate extinction, and I'm an environmentalist. And I found myself once working on a college that also had a ranch associated with it, grazing cattle on public land. So environmentalists are like, this is a totally fucking. Oh, sorry. This is a totally incorrect way of representing environmentalists, that they're anti-ranching. I think maybe many are, but not all of them are. Grazing cattle is actually complex, and it's not a black and white situation environmentally. But at that time, I found myself on one end of the extreme. And our college was trying to figure out how we can do this in a responsible way. And so the college, realizing that there's multiple stakeholders involved here, formed a team, including some biologists, me, and the ranchers, them, and some other people, some students, and a bunch of different stakeholders. And I tell you, folks, this was one of the coolest things I've ever been involved with, because I don't know about you, but we tend to live inside our little bubbles, our tribes of like-minded people. And I was forced to join a discussion group with people who had different opinions. And it wasn't just a one-off, or we could come up and state our position and fight with each other and say this to each other and walk away. We met again and again and again and again. We went out to dinners and we got to know each other, and we really shared our, and I found we had so much more in common than I thought, and it became a really good way of addressing this problem. All right, classic stakeholder approach. So get their input. Okay, so in the end, after you've done all this stuff, breaking down the problem has now been effectively crowdsourced. I love that new word, crowdsourced. We've done it. So good. And you do this because you want as many ideas as possible so you can best address the problem. Okay, so now you've talked about the problems. Now what about solutions? I just wanted to say that if you focus on a single solution, you're probably wrong. For instance, carbon tax will fix our climate crisis. Why do I say that? Look, if it were an easy problem, it wouldn't be a problem. It would have been fixed a long time ago. Most environmental problems are complex, and complex problems usually require complex solutions. I also say this because in political campaigns, a politician walking around saying things, being quoted by the press, making mailers, or in arguments with other people who are, good debaters, so often people will just focus on one thing. Red is good, and life is just not that way. Life is complex. So if you're trying to win an election, then maybe sloganeering about stuff is effective in winning the election. That's your real problem, not the environmental problem. But if you're trying to solve an environmental problem, then it's not going to be a single solution problem. Probably, I'm just sharing with you my point of view on that. Okay, so solutions. So basically repeat the crowdsourcing steps above. Sit in your armchair and think about solutions, get your friends together, get stakeholders together, repeat that process and get a lot of possible solutions. So there's many other steps after this, but we're going to stop here and just focus on the social aspects of problem definition and solution proposal, actually how we crunch this, how we gather data. Actually, I forget where we're going. It'll become clear in the PowerPoint. All right. Anyway, you now have a list of components of the problem, check, and solutions, a list of possible solutions, check, with questions about the human components of each. Okay. So in that list of things, there's going to be certain things that are very hefty human component. So not like, I don't know, what are the methods for keeping cattle out of riparian areas? It's not something that has a hefty human component. But backpackers in the area don't like cow poop in their camping areas. That's something that has a social component. So identify those, and now we're going to move into that. So let's organize these things. You have a whole bunch of ideas from your stakeholders, and you want to organize them in a helpful way. And how can you do that? You want to organize it in a way that shows the connections, because maybe different solutions have connections to each other. And they're like money usually is connected to a lot of things. And some might be more important than others. So how do you, just some tips to organizing all that stuff? Look, if you are a highly organized linear thinker, then maybe you can organize anything. Number one, number two, 1A, 1B, 1A, little one, etc. You can organize it that way if you're super good at doing that. But sometimes like priorities are not that clear, so you don't actually know what number one is or number two if that's a list of priorities in from greater to least. It's not always obvious. So another way of organizing things, I wanted to introduce the concept map. Oh, I'm sorry if my face is obscuring this. I'll read it for you. Another approach often used in group brainstorming meetings is the concept map. And this is good for, I just made up these terms, the synthetic free association thinker. That's kind of like me. I'm not naturally highly organized. I try, but often I fail, and I'm just not naturally that way. So what you might get after putting all these ideas that you've brainstormed with your stakeholders and put them up on a whiteboard somewhere, you're not going to get anything like this. So what I did is I just Googled concept map, and I got this picture, which is really, really funny because this is a map unlikely to result from a group meeting. This is highly structured map. I don't know if you can see it, but it's some biology thing. The endocrine system includes the pineal gland, the thyroid gland, the pancreas, the ovaries, the testes, the thymus, the adrenal gland, the pituitary gland. The pituitary gland is connected to the hypothalamus. This is perfectly organized, and this is not what you're going to get from a group meeting. From a group meeting, you're more likely to get something like this. Now, you can ignore the words inside here. Again, this is just, I Googled this, and this is more, it's messy. It doesn't matter what the words are here. It's more like this is connected to that. It's also connected to two other things, and those are, it's all over the place. But what I'm just saying is that when you do this, when you create this kind of concept map, it's really helpful to see the links between things. And also, it's good to see the big things, and then you can start thinking. It's one way of thinking about which is more important. You might discover some low-hanging fruit, some problems that are easily, I don't know, I don't have an example here. Maybe it doesn't matter what the words are here, but perhaps this issue right here, everybody agrees is, that's a no-brainer. We should all do that. Okay, good. Whereas something else might be, ooh, that's thorny, that's more difficult, that's going to require more thought, more planning, etc. We need to put more resources that way if it's affecting a lot of people. Okay, so again, this is just a way of organizing ideas for problems, potential solutions, etc. The concept map. Okay, so some common methods. It's a methods class. Let's talk about some other methods. Common methods of gathering information in the social science include human experimentation. Well, I mean, yeah. You'd kind of like to experiment on humans to find out how they work and stuff, right? That would work, except for if you did something bad, which you could do. So human experimentation has a dark history. And it is still practiced, But in the United States, it requires institutional review board, and at Humboldt, we abbreviate that IRB oversight. So any experimentation, whether it's like scientific, like drawing blood or measuring their height, or even doing surveys of humans, requires institutional review board oversight. Who's on the institutional review board? Actually, I don't know. Probably a mix of faculty and administrators, and maybe some lawyers as well. Hopefully, they're expert in the law as well as morality, or in various scientific methods. What is currently acceptable and what is not acceptable. Okay, so just so you know, you can't willy-nilly go experimenting on humans. You can't not experiment on humans, but we're trying to do it in a responsible way nowadays. I don't know if we always do. All right, common method of gathering information is conducting surveys. Is that not human experimentation? Maybe it's a subset. Anyway, surveys. You have written questions with either baked in or open responses. What do I mean by baked in? By baked in question, here's just an example. Last year, how many times did you personally visit a national park? A, B, C, D, or E. These are your only choices. So that's baked in. And by the way, I think this is a Likert question. Basically, Likert is from 0 to 10, how much do you blank? Or I liked it to I didn't like it kind of thing. And what it does is it takes a subjective response, which is how much you like something. Well, it allows you to take what will be a subjective response, like I liked it, I hated it, and convert it into an objective data. So that's cool. I tell my young scientist students that scientists measure things and they generate data and they analyze the data statistically. That's what scientists do. So if my students are trying to do some scientific project and they come up with a method that's not measuring anything or not measuring it well, then I have a conversation with them. And oftentimes if they're like, trying to figure out whether this paint will fade or dry more rapidly or slowly, I'm like, well, how are you going to measure how rapidly something dries if you don't have a paint dryometer? And so I then talk them about the Likert scale. And so then you can take what's subjective, like this paint is a little bit dry, it's more dry, it's really dry, and you can put that into a Likert scale. Okay, so this human experimentation, there's surveys. Surveys have either baked in, so the Likert scale is kind of what I'm calling baked in. And then there's open responses where you have like these kind of questions. How many times did you visit national parks last year? A few, 10 times, a lot. So you get, who knows what people are going to respond there. Even greater variability would be the responses to the second question. What were some of your impressions from your visit? People could write down anything. So that's cool. There's ways to analyze that kind of data, and you will be doing that in lab this week. Okay, so surveys can have in really good numerical stuff, and sometimes you're going to generate something else, which can still maybe be subjected to some form of numerical analysis or a subjective analysis as well. A qualitative approach is really, I'm sorry, I'm going to have to read this to you. Qualitative approach is where could just be qualitative on part of the investigator. So like the researcher could be a passive non-participant, just a fly on the wall listening to what people say, or I guess observing them with binoculars or whatever, just making observations and writing them down. Behavioral studies do that. Depends on what they're observing and how qualitative it is. Another one is where the researcher is a participant. So the observer is being the researcher is the participant. That's where the researcher becomes a member and like say, okay, I'm going to join this group and pretend to be a whatever they are and go and then just sort of take notes about their experience and then write it up. And then another qualitative approach is the interview. And so the interview is where you just talk to people and you ask them and you have conversations with them and you record what they say. And later on, you subject those answers to some kind of analysis. Tricky stuff, social science. It really is tricky. Here's one reason why it's tricky. Please note how easy it is for bias to creep into social science study design. And here I'm going to emphasize bias not on the part of the researcher, like asking, I don't know, a question that's just inherently biased, but more the bias on the part of the subject and how that would affect their responses. So instead of responding truthfully, their response is tinged by their own bias. And here's some examples. There's a bunch of them. So social desirability and conformity. Humans have a tendency to be socially desirable and to conform. So if they feel like their own society would answer a certain way, even if they would answer a different way, they're more likely to answer you the way their society would do. Or they might be thinking, the second part is tendency to be agreeable and acquiescent. That is, I just want to be nice to the researcher and seem like an agreeable and nice person, even though I'm actually not, and I have a different point of view. The order effect is important, where the question asked here may affect response down below. The example I saw was like if you give a brand name in one question, then in the next question, this person is more likely to recognize that brand and answer it, something like that. There's a tendency to inflate one's own prestige. So it's like, how many times did you win awards in your life? 12, when it was only 6. Tendency to perceive threat and respond accordingly. So if the question seems to have a little bit of an edge to it, the respondent might become defensive and not give their true response. Knowledge of the source of the survey can influence responses. I'll give you an example. I got a survey from a political party that is not my political party. And I'm like, oh, what do these guys want now? And I open it up. It's like, we want you to answer our survey. Your answer is very important to us. And they asked the questions about all their main issues. And since I disagree with them, that influenced my responses. I actually had fun. I answered all the questions exactly the way I thought that they would want me to answer, and then sent it back in as an attempt to poison their data because they now think I'm exactly the opposite of the person I actually am. Haha, showed them. Anyway, answer to one question may affect answer to a following question. Okay. So I think that's all I wanted to say. Yeah, this is the last thing I wanted to say. In putting together this part of this course, I had advice from the ESM departmental social scientists like Lori Richmond and Yvonne Everett and Jen Tarleton. And they said, look, you leave your students with this message. Because it's complicated. This stuff is tricky. Bias is really tricky. If you're ever serious about conducting a survey, have a trained social scientist review your questions and advise you on avoiding bias. So you're going to go in lab today and you're going to do Likert skills, you're going to do coding, you're going to do concept mapping, and I think that's what all the things you'll be doing. And that's fine. I hope you enjoy it. I hope you learn something from this part of the class. However, this is a deeper subject area. It's more complex than it seems on the surface. Make sure you understand that, and should you ever get into this kind of thing more deeply, just remember bias is super tricky, and to get the best data possible, you want to address bias to the best of your extent. Okay, that's all I want to say. Have fun this week. See you next week. Bye-bye.